Say, I am Larry Kohler, and these are they gave me these things. I didn't have anything else to do with them, so I put them here. CCNA, CCNP, and then the specialist, I have no clue. They said I'm a specialist for something. The way the new certification works, CCNA, and then within that area, instead of having multiple CCNA certifications like the wireless and the security and all that, you have specialty areas that you can do. Also, CCNP is a single test. It used to be a 3-test. It had one that was kind of interesting, troubleshooting, where you actually had to go in and troubleshoot and fix stuff. They had, I think when I took it, it had maybe 3 multiple choice drag and drop questions, and after that it had 13 labs that you had to go resolve. But anyhow, I have done this for a while. When I don't make sense, and I've done this long enough to know that there's going to be times that I don't make sense, please ask and let me try a different approach to what goes on with it. So the expectations here: keep up, ebook, do the labs, I think is the big thing. You're going to have to download NetSim 13 from Boson, boson.com. There is a set of instructions in the course material that shows you how to do that. You'll have to create an account at Boson, download, and you have to create it before you can download anything. Download it, and then when you start the NetSim, you'll have to log in with the same username and password that you created at Boson. They keep track of where you are with these things. This new process that they have is supposed to be a way to allow you to use the NetSim in various locations. Previously, and this is another history thing that you probably don't care about, but previously what they would do is give you an activation code, and you could install it on 2 machines. But now with the login process, you should be able to log in and use that particular software wherever you go, whenever you want to do. Alternate resources, Google is, as you probably already know or have found out or done or whatever, is my best friend, probably your best friend too when you in the IT world. There are lots of answers there. Different ways. If you don't get the answer you want with one set of words, try another set of words, and you get an entirely different set of materials. This is the entire course, the ICND, and these parentheses here are the old ICND1 and the old ICND2. In YouTube, my YouTube, there are some ICND1 playlists and there's some ICND2 playlists, and these are the materials that should be covered in those particular areas. Nothing really, I'll say nothing really magical, but maybe it will be magical. The big thing is when we can configure switching. We're going to be in configuring switches. The thing that we until I started getting into it, is just some place that you plug the computers into. Well, there's a lot of configuration that goes on with it. So the network fundamentals, which we'll do today, and hopefully I won't bore you too much. Then we'll do switching and IP addressing, and then we'll do routing, and that will take care of this week's. Next week's is wireless IP network services, and the network services are things like DHCP, DNS, time, the things that support the network. And then security fundamentals, we'll get back to, we'll get into access control lists, and we'll also get into layer 2 security at that place. The last day, next Friday, automation and programmability, which is mostly going to be just a lecture. These others are going to have some labs. Today got very little bit of lab, but a little bit of lab to get you acclimated, hopefully, to the NetSim. It's a little different. It just takes a little bit of getting used to in order to use it. Some characteristics, I guess, of the iOS, the Internet Operating System that Cisco uses, are available in it, are useful in it. And then the troubleshooting, they have had set up at the end as a single troubleshooting day, lecture, whatever. We've incorporated the individual elements of troubleshooting into the material itself. So when we do switching, the troubleshooting, switching will be part of switching, and routing and the troubleshooting, routing will be each of those. Okay. Anyhow, the troubleshooting we'll do there. So the network fundamentals, things that you have done, have been the experience that you had, the courses that you had, and again, hopefully we'll get into the models again. But today's the network fundamentals, the things that we'll talk about: the network types, the network components, transmission media and connectors, the topologies, the models, everybody's favorite, the OSI and the TCP/IP model, basic protocols, and then we'll get into, near the end of the day, the networks and the iOS commands, and troubleshooting methodologies, troubleshooting interface and cable issues, the things for today, the objectives for today that we'll do. So the first one here, network types. This is one of those, been there, done that. Some of these things don't show, and I kind of do all these things at the same time. But networking, and there are lots of different networking. You probably do social networking of some type. Even I do of some type. I use LinkedIn, which is a social networking. So in order to do these things, say an application that wants to communicate with another application, one of the other things that we can say is that we have somebody that has something and somebody or something that wants something, and the application is the way that we do things. Social networking is the way that I got this job at LeaderQuest. After I had retired at ECPI, it gets to the point that, maybe I want to do a little something. I don't want to work. I was working 30 hours a week there. I don't want to work that much, but maybe a course every once in a while, and I do 2 a month now, basically for LeaderQuest. So on my LinkedIn, social networking, I put a retired IT instructor would welcome part-time work. And I got a message from LeaderQuest, would you be interested in doing something for us? So we had an application, LinkedIn. We had somebody that had something, wants to communicate with another application. They wanted to communicate with me, and I wanted to communicate with them. And then we had a common language, a protocol. And the common language that we used to communicate was English. The common language that we used to network communicate with was TCP and IP in order to do those things, and HTML up at the application layer to do those things, so that the two sides can be used to communicate. Network interface. I used an Ethernet card or a wireless, or one time we used a telephone to do these things. So network interface that allows the nodes to connect. We've got to at some point put the data onto the media, the transmission medium that carries the data from one node to the next. You may be using wired, you may be using wireless on your systems to do that, but we have a transmission medium. It could be fiber, it could be copper, it could be the atmosphere to do those things. So what we have are all these elements, that the 4 basic components that make networking possible: social networking, digital networking, whatever kind of networking that you're using for these things. So an application, or somebody that has something and somebody that wants something. Common language. And the common language, if you say that you're looking for a job or change a job or a new career or whatever else, and that you go onto a job board and there are jobs that are advertised, but maybe you got to speak Chinese. Probably not going to work out so well. So we have to have a common language or a common protocol for these devices to communicate. And I'll say, as we go through these things, I'll say off and on that, yeah, we used to have a lot of other protocols. We did used to have a lot of other protocols. But now, basically, what we use is TCP/IP as the way to put it on the wire and communicate from one to the other. The applications themselves are going to talk to each other. A web browser will communicate with a web server. An FTP client will communicate with an FTP server application. Common language. We have to have some sort of an interface to connect us to the medium, and then we have to have some sort of a medium. Medium is multiple media in order to send the information from one location to another location. I'll get out of this thing in a second. So the common network types, and these are things that you've seen these abbreviations before: the LAN, MAN, CAN, PAN, WPAN, and the PAN and the WPAN are the ones that this book, and this is out of the book that's provided, is a little bit different definition than I've always seen a personal area network were personal devices that were connected together to do those things. They distinguish between a personal area network and a wireless personal area network. And then a WAN, a wide area network, is going to connect other networks together. We talk about these things in descriptive terms. A LAN covers an area that is small enough to fit in a building. Could be a building, could be and I'm going to say an IP network, and I'll mix terminologies here. A LAN under a single administrative control, it could be more than a building. It could be a couple of buildings. It could be a room. It could be several rooms in order to do those things. But when we look at the models, and those of you who have had Network Plus have talked about the models, the OSI model, the TCP/IP model. The real differences between all of these, and we'll talk about these again if you haven't, but just a note to self, the difference between all of these networks are all defined at layer 2, the data link layer. What kind of protocols do we use there? In the LAN, we use the TCP/IP. In the WAN, we're going to use things like EIGRP, OSPF, PPP point-to-point protocol. Wireless, we're going to use the wireless protocols. 802.11 definition is going to be there. The local area network, Ethernet 802.3. The MAN, I don't remember the 802. The metropolitan area network has its own, but it covers an area equivalent to a city or a municipality. A campus area network, academic campus, a military installation, something like that, a single entity, but it's still going to be under a single administrative control. And then a personal area network are the things that we connect to our personal devices. The personal area network, 2 or 3 computers, cables, most often seen as small office, home office, and the wireless personal area network, variation of PAN. And I think that in the personal area network, you can include things like, printers that are connected to the devices. The things that connect together, USB devices, would be part of a personal area network arrangement to do those things. Wireless personal area networks, again, we got the printers that we could have for those. We could have maybe a headset to do each of those things, a number of devices that are connected there, and then a WAN, a wide area network, is going to connect local area networks together. It's going to be a network of networks that we connect different localities and covers a large area. Usually the distinguishing factor in a wide area network is we don't own the media. We don't own it. We lease the lines from somebody that provides that service to us. The others here, local area network, a building or group of building, a metropolitan area network, campus area network, personal area network, we're probably going to own the media. We have control of those networks. A wide area network, we're not going to have control of the network. we're going to lease that or rent it from somebody else to do those things. Some images here, and I'm big on pictures because, again, I'm kind of dense, but nothing really magic about it. Try to do illustrations. Sometimes they work, sometimes they don't work. But the campus area network are a limited geographic area, campus, military base, something like that. And you notice here it's got different buildings that are now connected together. We're going to have some kind of media to do that. I was the network administrator at a place, Blue Ridge Behavioral Healthcare. We had 12 different physical locations that we had to bring everything back to the headquarters activity with. And within some of those installations, we'd have something like this set up that had multiple buildings within a single physical location. Some use wireless, some use wired in order to communicate from one building to the other. So campus area networks, metropolitan area networks, different protocols, different media, different ways to communicate with these things, to go from one to the other. The personal area network, and again, the PAN nodes, and this one shows some wired and wirelesses, and this is what I've been more accustomed to seeing for a personal area network. We've got cameras, game pads, printers, phone, the stereo here, camcorder, different things connected to it. And then we have the wireless devices that are connected to it that we can use. And it could be things like a headset. You could use a Bluetooth headset would be part of a personal area network that connected one device to another device. So personal area, and personal means really short range when we do those things. Short range, how long is the wire for a USB? What's the range for a Bluetooth device? And they vary depending on which version of Bluetooth that you have with these things. The LAN, MAN, WAN kind of conceptually what goes on with these things. A wide area network is wide area across the world. The biggest wide area network in the world is the internet, obviously. And we can get information. You can go to the London Times and get it. You can go to the Washington Post and read those things. We can communicate worldwide with this. And the difference between it is going to be the media, obviously, and the way that we put the signal on the wire. And the way we put the signal on the wire is going to be the layer 2 protocol that dictates that. The metropolitan area network kind of falls in the middle there. And the images here should show that we don't have to go through a metropolitan area network and get to the wide area network to do these things. Metropolitan area network within the metropolitan area, and then it connects to the wide area network. These local area networks can connect directly to the wide area network, and that's typically what we do. And even our SOHOs, our small office home offices, are going to do that. We connect, actually we don't connect directly. I guess we go through an ISP, and then the ISP is going to take us to the internet, to the wide area network. But communities, we build these things in order to get into the networks themselves. The internet's become, a necessity for most businesses today. So local area networks here are self-contained networks that they can span a small area. Single building, could be a floor, could be a room. Faster data transfer. And what you will typically find in all of networking is the shorter the distance, the faster the speed. And you can start out with the CPU in a computer. How fast does the CPU operate? And then how fast does the memory bus operate? Once we get onto the internet, or into the internet, onto the NIC, onto the network itself, how fast does it operate? And most of us are probably got gigabit NICs in our machines and probably a gigabit switch. And the protocol is going to dictate that. Wired going to be faster than wireless. We look at the wireless and say, oh, we got an 802.11n and we're going at 600 megabits per second. I look at my wired NIC and I'm going at a gigabit per second to do these things. But faster data transfer. And then when we get on to the wide area network, when I do a speed test, the absolute best that I get, which is what they're selling or advertising that I have for my wireless connection to the ISP is 200 megabits per second. So we're going to generally go slower the farther that we get away from these things. But the local area network doesn't require leased lines for communication. We own the topology in these typically. And they're under a single administrative control, single management, single network administrator. You may have, techs or other sub-administrators, but at some point, an organization is going to have a network administrator that's going to be in charge of these things. Don't require leased lines. Multiple nodes and segments that directly connect with cables or short-range wireless technologies. We're going to incorporate both wireless and wired connections within the local area network. Used to implement different technologies depending on the configuration and operational requirements. Different technologies are what we're going to use, and the technologies, the protocols, the technologies that we use and the devices that we use are varied and multiples that go on with these things. The protocols that we use used to be, but at one time, so my first certification was NetWare. NetWare used a proprietary protocol, IPX. And NetWare, and the way that it worked was before the OSI, so they kind of built their own model. They actually had a 3-layer model. But it was a protocol that wasn't compatible with another protocol. What we've come to in this era is a common protocol that we use for networking, for local area networking. The 802.3 or local, for the local, for all networking. Once we get out of the, whether we're a LAN, a WAN, a MAN, those sorts of things. This TCP/IP is the common protocol that we're going to use in order to communicate among all of these different resources when we do these things. The next one here, let me see how many we got, is the wide area network. And we'll do that and then we'll take a break. But the wide area network covers a large area and is usually spread across geographical locations. And the objectives, when we look at that, I think these are the two ones, you need to know about these other things, but the ones that they really emphasize are the LANs and the WANs. What we're interested in the CCNA in today's world is the enterprise. The enterprise is going to be us, going to be on the local area network, the things that we own, to be able to manage it. Most of the wide area networking has been taken out of CCNA and put into CCNP to do these things. But a wide area network, large area, geographical locations. The thing that I talked about at Blue Ridge Behavioral Healthcare, the 12 physical locations. In order to communicate among those 12 physical locations, we had a wide area network. We used a wide area network. We used an ISP. We actually used Cox Cable. We used a cable provider, cable modem to do those things because we didn't have enough people at any of those individual locations that would overload that type of connectivity. So what do we need? We need somebody else in order to help us communicate site to site. Because the city's not real wild if we want to go out and pull fiber or pull wire from one place to the other. We have to either lease the lines or get permission to do that, do our own wiring. And typically it's going to be cheaper to lease the lines, to lease the wide area network. And just like you and me, we're using a wide area network, and you're probably using a cable provider of some sort in order to be in this class, in this meeting that we go to. And all the networking that we've talked about, yeah, we have an application. We all have an application. We've got the Zoom app. We've got a media, be it wireless that you're using to communicate to your router, or be it wired that you're using to communicate to your router. We have a media of some sort, an interface and all of that stuff. And then when we get off of the router, it uses probably a different type of media, a different protocol in order to go from one to the other. So WANs, provide access outside of the local area network, connectivity between locations over long distances, and then connect disparate LANs to make one large intranet to facilitate corporate communications. ECPI had, I think, 15, and these were widely dispersed. They weren't within a kind of a local area, widely dispersed areas, and we used the facilitate corporate communications. Everybody communicated with the corporate headquarters. We were in Roanoke. The headquarters was in Virginia Beach, Virginia. Yeah, one Portsmouth, Greenville, South Carolina, Charlotte, North Carolina, various locations. They one in Northern Virginia, but wide area network, leased lines in order to do those things. And the wide area networks can be private or public, combination of both. Wide area network, the biggest one in the world, the internet, the thing that we're using. The private, the different enterprises that lease these things. I don't know if LeaderQuest does that between their different sites or not. ECPI did. We were able to communicate, but we had to communicate through the headquarters activity in order to do those things. So I want to leave this image up here, wide area connectivity of local area network, and let's go ahead and take a break. So we have the wide area network connectivity image, just different local area networks connected through the magical cloud that we all use in order to get from one location to the other. The cloud is, and if you look at it, is a great, huge switched network. And there's just kind of an interesting article I saw the other day that in the cloud, the wide area network that IBM's cloud network got taken down because somebody had hacked into the routing tables and sent bad routes to them so that they could get from one location to the other. So lots of things that have to be taken into account and managed when we're actually doing the networking of the devices themselves. The connectivity options, and then the connectivity, one node can communicate with the other. Nothing, I guess, spectacular here. We can be wired or wireless. Wired includes copper and glass. The RJ45 connectors or the fiber connectors are going to be used for this. Wireless, any physical medium, something we can reach out and touch. Wireless, we're going to be using the atmosphere as the medium, as the layer one when we do those things. The wired network, cabling. The neat thing about cabling is we can see where the signal goes. We can see where the signal is supposed to be. It's going to go around the wire. If the wire is coiled up, it's going to go around the coil. If it's a straight line, it's going to go in a straight line. Wireless, we don't really know. Wireless is one of those things that you really got to pay attention to because it can change, and we'll talk about wireless next Monday. It can change distances and paths based on atmospherics, what's going on in the atmosphere. So we can have wired or wireless to connect these things together. Get back to this thing, the Ethernet standard, the wired standards for LAN connectivity 802.3. We're going to have Ethernet, the original 802.3, which was a 10 megabit per second standard. Fast Ethernet brought us up to 100. Gigabit Ethernet, and then the 802.3AB, I think it's 40 gigabits. So we're going faster and faster and faster over copper. Originally in the Ethernet and the Fast Ethernet standard, in these connectors, and if you can see it and count them, you can see that there are 8 wires there. We only use 4 of them. But now in the higher standards, we use all 8 wires. The reason we use 4, the original concept of this wire pair, and we'll look at the pairs here in a second, was that we would be able to use 4 of the wires for data and 4 of the wires for phone, so that you only had to have 1 drop to go from one to the other. Copper or fiber cables are a combination of both, and the copper generally going to be for short ranges, fiber originally for long ranges, but now we also use it in short range. Typically we can go farther, and I get ahead of myself in a lot of these things, and we'll do some of these things over, but when we put a signal on the wire, we'll start out with a signal up here, and as we go in copper, it will degrade. In copper, we have noise that gets induced into it. What we have to do is regenerate this signal before it gets below the noise level, so that the system can distinguish between what's signal and what's noise. In fiber, we don't have this noise issue, so that we can go a lot farther before we have to regenerate the signal. Eventually, we have to regenerate the signal, not amplify, but repeat. And the repeat the signal renews the signal, brings it up to its original strength, so it can do the same thing again. In this copper, generally for short ranges, copper or fiber, there are some media that have both copper and fiber in the media. Fiber, generally, again, long ranges. One of the issues, I guess, is that the fiber itself today, with the amount that's available, is not all that much more expensive than the copper. It is more expensive. But if you go to make fiber, the tools that you need are really much more expensive. A fiber microscope to inspect if you're making one at a time can cost upwards of $10,000. The copper ends, the ones we're going to use, the straight tips or the others that we would use, cost about $5 a piece. The RJ45 ends, the connectors, probably about 75 cents a piece. To make an RJ45 connector, you can go to a hardware store and buy a crimper a pretty good crimper for somewhere around $40, $50. So the tools that you need in order to do fiber are much more extensive than you would need. Needing a certification for fiber, yes. And I had that one at one time too. I thought fiber was fun to make. The new systems, and one of the courses that I did in Charlotte, North Carolina, was for AT&T, and all the students in there were fiber techs, and they have fiber trailers. You see these guys out running the fiber, to putting in all of the new internet connectivity, and they have these trailers that put these things together. When he worked with it. So Justin, yep. When it was Lockheed, yep. It's kind of neat to play with, kind of neat to do. And basically, and correct me when I make mistakes on these things, what we're doing individually when we were doing the fiber courses and learning how to do it internally, is you're basically taking this thing and smoothing out this piece of glass, very flexible glass, and gluing a connector to it, making it butt up so that you didn't lose the signal to it, butt it up and glue it together to do these things. And you can connect the fibers together, and what they're doing with the trailers typically is putting together big groups of fiber, something like maybe is in the image here, putting them together so that we go from one to the other. But anyhow, I thought it was kind of fun to make that, to play with. The first one I made, I said, oh, I'll polish this real quick, and then I fractured it. And you can fracture these things when you do that. Ethernet cabling itself, and then what we have here is kind of an image of what goes on, and I'm going to scroll on this for a minute, and then we'll look at the automated what each of these things mean. So in the Ethernet cabling, what does all this business mean? So what we have is in these things 100 base TX. The 100 here is going to be the speed. So this 100 is 100 megabits per second. 10 here, 10 megabits per second. And when you see these things, small b is bits and big B is bytes. And I'll make a mistake on that. We have baseband here. Base is baseband, which means that baseband, which means that we have one frequency, one signal to do these things, one frequency to go from one to the other. And the end here, the TX, the T is going to be twisted pair. T for twisted pair. This one's a little bit different here. The 10, no problem. 10 megabits per second. Base, no problem. Baseband. And then we got a 5 here. This tells me that it's coax. We have 10 base 5 and 10 base 2. And the 5 here says that it's 500 meters. Typically what we're going to have, and if you don't know any better and you're asked a question and you need to know a distance, the standard here is going to be 100 meters. But in the coax, 10 base 5, 500 meters. And then and this is thick coax. And then the other one, 10 base 2, is 180 meters. And I don't know where they came up with that. I guess because they couldn't do 180. They just used a single number here. So 200 is the closest thing. 10 base 2 is 180 meters. And this is for each of the runs. When we talk about Ethernet, it's going to be for each of the Ethernet segments when we do these things. The connector types here, RJ45. AUI is an auxiliary unit interface. What it does, and we'll have some images of routers a little later, in the early days of routers, and we still do these things, they still come up on what do these terms mean. What we had was an interface on the router itself, which connected to an AUI. And the AUI had a common that would connect in here, and on the other side where the media connected, we could either get one that used RJ45 or we could get one that used coax. And the AUI was the adapter for what kind of media that we had to do these things with. The NIC MDI, and MDI is media dependent interface. When we do this, what this says is that, and the X is the crossover, whether we do it automatically or not. You probably have seen these things before, but like to like, and we're going to talk about the type of cables we have in here in a minute. We're going to be a crossover cable. And like to like means that we go NIC to NIC, switch to switch, hub to hub. A NIC on a router to a computer is going to be a crossover cable. This is a straight through cable, so the unlike use straight. And the reason they use a straight is we have the transmit to the receive in the devices, and this says a hub, but a switch is going to do the same thing, a switch or a hub. For the unlike device, we have the transmit pair and we have the receive pair. The reason that we have to do a crossover when we have like devices, if we don't, we would be sending the transmit to the transmit, NIC to NIC. We would be sending the receive to the receive, which means that we wouldn't be communicating. In the unlike, the NIC to switch, and it says hub, but we want to think in terms of switches because that's what you're going to see today. NIC to switch, the transmit goes to the receive on the switching device, so that we transmit to the receive portion, and then it transmits back to our receive pairs to do these things. When we do fiber, we have to have two fibers to go into a system also. One of them is going to be the transmit fiber, and the other one's going to be the receive fiber. The RJ45s, we have the transmit pair, 2 wires, and the receive pair, 2 wires. We don't really see that because we have a single interface that we connect it to, the RJ45 interface that we connect it to. But we still do have the transmit and receive, and the NICs are transceivers, a transmitter receiver to do these things. In the Ethernet cabling over here, the specifications are defined by the EIA-TIA 568, I think, 568A and 568B. Once you decide up on a standard, you need to stick with that standard. Because if you want to make a crossover cable, and a crossover cable crosses pins 1 and 3, 2 and 6, let me make it a little thicker here. So if we have a like to like, and we say that this is our, this would be our transmit, and this would be our receive here. If we go from 1 to 3, 2 to 6, 6 to 2, 1 to 3, we've now sent the transmit to the receive, and that's why if we have the likes, we need to use a crossover cable so that we send the transmit to the receive and the receive to the transmit for these things. But the EIA-TIA 560, I think it's 568, but you gotta get the numbers right. 568A and B. If you make one end an A and the other end a B, you'll have a crossover cable to do those things if you need the standard. But remember, cross 1, 3, 2, and 6 in order to make a crossover cable. So we vary the connector type, the maximum cable length, and the physical media used are going to vary for each type of network. And typically what we're still using, I think, what we were using the last time that I did one anyway, which is about 4 years now before I actually worked on a network. I've been doing these classes since then, is we were still using copper. 100 meters. Gigabit Ethernet, fast Ethernet, the different standards that we had available to us in order to get the information from one to the other. You know, 100 meters is a long way. And when we put these devices, the switch in here, the switches become repeaters. They rebuild the signals so that we can go from one switch to, you know, from a switch to switch 100 meters and another 100 meters. 100 meters from the device to the switch to do these things. Coax, the very first network that I was on was a coax network. Hopefully you're not going to see that when we do these things. And then the types of cables that we have, we've talked about the straight through to unlike devices, the crossover from like to like. There is one other type, it's a rollover cable, and the rollover cable goes 1, 2, 3, 4, 5, 6, 7, 8, 8, 7, 6, 5, 4, 3, 2, 1. You connect pin 1 to 8, 2 to 7 on down the line. If you have to make a rollover cable, if you make one of them with the tab up and one of them with the tab down, you'll have a rollover cable. You say, why do I need one of those? This is the cable that's used to connect to the console port when we want to do direct connect configuration of a router or a switch. Because routers and switches don't have keyboards and mice and monitors on them. We have to connect something to them, and we connect that something to them using a rollover cable. And then how do these things without using that is the console cable. When you buy a Cisco device, and we'll have some pictures of it here, you'll get called a console cable, which is a rollover cable. It goes from the serial port, which we don't have anymore, to the to the console connector, which is an RJ45 connector on the other end. So what you use in today's world typically is a USB to serial converter, and then we're going to use, we always just made it RJ45 to RJ45 connector so that we could go from our dongle directly in. The Cisco device that you get is actually a serial at one end and an RJ45 at the other, but it is a rollover cable to do those things. Yeah, and PuTTY, exactly what he says there. PuTTY is going to be the connector, and let's see, I think I have a PuTTY here. What we're talking about when we do that, what we're talking about is the program or the application that we're going to use to do the connections with. Can't make this any bigger, but when we connect to it, we have the serial connector here, which will, and this says COM1, this is going to be the serial port that you would connect from the computer using it. When you use the dongle, the converter, the USB to RJ45, or the serial actually, and then from the serial to RJ45 on down the line. If you just use the serial, the Cisco cable, it has serial at one end. You're going to have to go and determine which COM port it opted on. If you have an old laptop that has a serial connector on it, hang on to it, because you can use it to do configuration on the devices to go from one to the other. And it's only going to have two COM ports, COM1 and COM2 on it. A lot easier to figure it out. You can use this for other things, secure shell, telnet, and we'll look at it again a little bit later, at what kinds of things we can use with it. But yeah, good old PuTTY to do these things. The crossover, the straight through, and then what we have here from an MDI, which is the media dependent interface, to an MDI, if we're going to do a cable requirement, MDI to MDI, like to like, we need a crossover cable. To an automatic, and the MDIX automatically makes the decision as to what kind of a cable that you need to do these things. And you say he kept an old Toshiba laptop and run Linux on it just for this reason. Exactly. If you have an old laptop that's got those kinds of things on it, because it's not going to require any kind of a horsepower, but all you're doing is transferring keystrokes from one to the other to do these things. Anyway, the MDIX, the ones, the hub or the switch down here that is built to receive the transmit on the receive side and send to the other side, is going to require a straight through cable. The auto and the auto MDIX, auto MDI, MDIX, automatically detect the kind of cable and the kind of cable that's needed. The routers that we have at home, the wireless routers, when you plug something into the switch port, it's going to automatically configure whatever you need. If you need a crossover cable, it's going to say, hey, I need a crossover cable. So let's do that based on the signaling that goes on. Some of the new Cisco devices have this. The other ones, the 2600 switches, for instance, don't have that configured to do that. So that if you're going to connect two switches together, for instance, you're going to have to create a crossover cable in order to connect those devices together. This is something that, one of the little things that can get you is you're going from the NOC, I got a switch in the NOC, I got a layer 3 switch in the NOC, and I'm going to a layer 2 switch in the room, and they're not connecting because we probably have built it as a straight through cable, and we need a crossover cable in order to do that. Some of the little things that can happen, and I tell you, one of the reasons, the difference between you and me is I just probably screwed up a whole lot more stuff than you have when we do these things. But what do we need for each of these things? The auto MDI, MDIX can be any kind of cable. Straight through cable, 1 to 1, 2 to 2, 3 to 3, on down the line, 4 to 4, 5 to 5, 6 to 6. The crossover cable, 1 and 3 pins, 1 and 3, 2 and 6 are crossed in order to do that, in order to connect like devices together. The well, let me get back up here to the straight through cable is going to be unlike devices. We're going to connect a computer to a switch. We're going to connect the Ethernet connection or the gigabit Ethernet or the fast Ethernet connection from a router to a switch. We're going to use a straight through cable. Crossover cable, unlike or like devices, NIC to NIC, so that we send the transmit to the receive and the receive to the transmit on down the line. The MDI devices, MDIX devices do that internally. The crossover cable to connect to our console port, 1 to 8, 2 to 7 on down the line. And again, if you have to build one of these things, just make one of them with the tab up and one of them with the tab down, and you will have a crossover cable. The straight throughs and the crossovers, what we have, 568B, 568A to do these things. And this all shows 568B. The 568A standard is the one on the right here. The 568B standard is the one on the left. The B standard is the one that we used consistently. And again, once you decide on a standard, you need to stick with it. And looking at this thing and saying that, hey, we've got the B standard on one side here, we got the B standard on one side here, and the A standard on the other side here. If you switched in the middle, you've just created a whole bunch of crossovers because you've changed from one standard to the other. So once you decide on the 568A, B, or the 568A, and I'll have an A in here, but once you do that, you need to stick with it. And then the rollover, 1 to 8 on down the line to do these things. 8 to 1. Cross the wires over, and it is again the console cable is probably the term that you will hear used with it. The cables and the limitations, kind of a nice little chart here when we do these things, and what we did before, 10 megabits per second, 10 base T, 802.3 is the formal IEEE standard. Each of the letters after this is a modification to the original standard. So you notice they all start with 802.3 something. 802.3 is the original 10 base, 10 megabits per second category, Cat 3 cable, different categories of cables, and that's the maximum speeds that they will use. Then we go to the 100 meg fast Ethernet, gigabit, 10 gig, 40 gig, 100 gig. These are when we change media, when we get down to the really high speed. 40 gig, we can use copper, but we can't go as far, 30 meters, Cat 8. The 10 gig, we can do copper with up to 100 meters. So the 100 meters is for copper is the number to remember with these things. The fiber, we get a lot longer distances to do these things. The 10,000 meters here for the gigabit Ethernet copper, we can go 100 meters. 10 megabits per second copper, we can go 100 meters. 100 megabits per second copper, we can go 100 meters on down the line. And then we get into the fiber, 40 kilometers here for the 10 gig. And when we start getting into the 40 kilometers and the 10,000 meters here, 10 kilometers, to do these things, the short range fiber, and we'll talk about fiber in a minute, but get this in, the short range fiber typically is going to use an LED as the light source. The long range fiber is going to use a laser as a light source. It's going to be a lot more powerful light in order to send it from one to the other. And when you're doing fiber, if you're working around lasers, and I would say even the LEDs, you don't want to look at these things. If you're with lasers, lasers cause permanent eye damage. So you really don't want to fool around with those things. But the different speeds here, the baseband, broadband, to go from one to the other, and then the twisted pair, the type of connector that we have here at LX, we're talking about when we get into these things, the type of connector, and we'll look at the connectors here in a little bit for the fiber, but we're talking about fiber when we do these things. The different categories here, we have the 5E, 6, 6A, 7, 7A, and 8. 5E, gigabit per second, there's 4 pair. Cat 5, we can use that. With a Cat 5, we only use 4 of the pair. But again, the distances that we go, 100 meters, 100 meters, 100 meters, 100 meters. So one of those things, what are you going to do? You know, the standard is 100 meters. Now you got to do is going to look at the exceptions to see what the differences are. Some of the other terminology that we would have here, different charts of what we have, the Cat 3, 5, 5E, 6, 6A, and 7, the cable type, UTP, unshielded twisted pair, until we get to Cat 6, UTP or STP. UTP, unshielded twisted pair, STP, shielded twisted pair. And when you look at the max data, 10, 100, and 1,000, what that means is, and when you look at switches, you'll see this also, 10, 100, and 1,000, that it can operate at any of those speeds. A switch which has that capability, if you plug a 10 megabit per second device into it and leave it at its default, it'll automatically negotiate to run at 10 megabits per second. 100 megabit per second will negotiate 100 megabits. 1,000, a gigabit on down the line. So the different types of media that we would have here, and then the maximum bandwidth. How much do we have here for bandwidth? And the bandwidth in this sense is the difference between the upper and the lower. We talk about bandwidth, and bandwidth can mean, unfortunately, a couple of things. We talk about bandwidth on the internet. We say our bandwidth, put the bandwidth, 100 megabits per second. That's actually the data rate. The bandwidth itself is a frequency range, the low to the high. And why is this significant? If we have this much bandwidth, and then we have this much bandwidth, as we increase the bandwidth here, we got 250, 500, 600, we can put more signal in here. So the bigger the bandwidth that we have in these things, the greater the signal, more signal that can go on these things. Out here we have 16 meg, 100, and we stayed at 100 for a while, 250, 500, and as we go on up, we increase the bandwidth. The amount of data that can go into any of these changes, we go from one to the other. Kind of a summary and an image of what goes on here. UTP, unshielded twisted pair, consists of pairs of wires twisted together, one of the most basic methods to help prevent electromagnetic interference. So now that I've introduced that to my electrical engineering days, if we have parallel wires here, copper wires, and we have a noise signal that comes in, it will be induced into the other one because that's what copper does. It will accept the signal. So now we put a noise on, and if we have noise on, both of these things are going to start amplifying what goes on. If we twist them, what we would have is one signal that does this, and another signal that does something like this. It's not going to be quite this clean, but when we add these two together, we get a 0. When we add these two together, we're going to get a 0. So by twisting and physically shifting the wire a little bit, we cause some noise cancellation on the twisted pair. And the pairs are twisted, and you can see the twists here. They're also twisted within the casing, the PVC outer covering to protect it for these things. Then we have STP, shield twisted, or foiled FTP, foil twisted pair. The shielded offer an additional layer of protection and shielding, also called screening, when we do these things wrapped around the individual twists or individual pairs, protects from EMI and crosstalk. It's going to help keep some of this noise out, or help keep the noise out. And then we have the shielded or screened and foil twisted pair. How much do we have here? And on this one, we're going to have some shielding on the outside of the pairs themselves, and the foil unshielded twisted pair. The pairs themselves are not going to be individually wrapped like they were up here with the FTP, with the foil twisted pair. The SFTP, shielded and foil twisted pair, we got the shielding around the pairs, and then each of the pairs are individually wrapped with shielding. And these are all designed to prevent noise. And as we prevent noise and we do more of that, then we have the better capability to put signal on, because the signal strength of the signal is going to not be interrupted by the noise that we have in the systems themselves. In the fiber world, these are some of the things that we have here. The duplex mix for these things, SFP, the small form factor pluggable. And I think we got some images here to do these things. The multi-mode fiber and single mode fiber. Differences is single mode fiber are going to be much smaller core. Was a 9 micron core. Micron is a millionth of a meter, a micrometer when we do these things. And the distances that we can go, single mode fiber, probably going to be using this laser for the high powered light that goes in these things. But there's a lot of protections, I guess, around the fiber itself. We have the core here, which is the glass, the very center of it. We have cladding around it, and then we have some coating, and then we have the strength member and the outer jacket. The strength member is to prevent breaking, and you can break this stuff if you work at it. And if you don't radius it correctly, the light won't go around it. So the ability to create these things, to radius them properly, radius when you go from one to the other, how sharp of a bend can you have, how big of a curve can we have on these things. But how far do we go with each of them? It's going to vary a little bit from one to the other, but 550 meters, 10 kilometers, and much farther, much longer range. We had a little earlier, 40 kilometer to do these things. So they're ultra thin strands of glass, and we're going to put light through them. If you build fiber, please follow the safety precautions, the goggles and the cleanup, because this is ultra thin strands of glass. It will cut you. If you get it in your eye, it's going to be really uncomfortable. So follow the precautions, and if you leave the bits laying around, somebody can get them embedded in their skin. It's going to be very painful for them or you if you do those things. Variety of longer Ethernet distances for these things, less interference from outside sources compared to copper, and the less interference would be somewhere around none, because we can't have EMI. Copper allowed the noise to be amplified, to be induced from one to the other, and we had to use the twist in order to do that. We're still going to have some noise on these things. We're going to have to repeat the signal much more frequently with the copper, because as the signal strength decreases as we go down the copper, the resistance of the copper, then the noise can't overcome the signal. We need to be able to, we need to be able to repeat the signal in order to do that. Fiber, we're going to go a lot farther before we have to repeat the signal. One of the things that makes it go a lot farther. Two types. We're going to multi-mode fiber and the single mode fiber. Many modes, and the many modes here, shorter distances, cheaper cable, and shorter wavelength for these things. I like to think about multi-mode as we're going to have multiple colors that go around here, because when you look at the spectrum, the light spectrum, we've got different colors, different frequencies of these things, different elements of multi-mode that can go from one to the other. They get retained, we call total internal reflection. They get bent back into and actually get refracted back into the core in order to go from one to the other. But in the multi-mode, we've got different light signals going down the system. I have an image here in just a second. The single mode is going to be a smaller core, one mode, one frequency, one light color, signal propagation. Longer distance is going to be more expensive, longer wavelength transmissions for these things. And the multi-mode and the single mode, the light sources are going to be different. The shorter distance, we're going to be using LEDs. What you would use for your speakers or to connect to your TV for those things. Different things are going to be multi-mode, shorter distances, and actually they may be plastic. They do make a plastic fiber. It's not all glass. It doesn't break as readily. And you think about where would you want to use it? Probably want to use it maybe on airplanes where you have a shock. Particularly, you guys were in the Navy on a carrier, which if you've ever done that, it's a pretty big shock when it hits the deck. So we're probably going to want to use something that's not going to shatter as readily for those things. So single mode, multi-mode fibers. The abbreviations for these things over here on the left, the optical cabling type. The S is a short wavelength transmissions. The L is long wavelength transmissions. And the X, this one missed a little bit, is the type of waveform modulation when we look at these things. And the F is going to be F for fiber when we look at these things. The image of what we have, the 62.5 micron is one of the standards for multi-modes, and then we have a 50 micron, and then the 9 micron that we use for the single mode, and the comparison for how much area is in the glass itself, in the core itself. The 125 microns is, if we go back to that, that's going to be that's going to be the cladding and the core itself are going to be in there. The multi-mode here, multiple signal paths. The single mode is going to have a single path that goes from one to the other, that the signal uses for these things. And then the fiber optic cabling itself, the colors of the jack, I'll have some pictures I think in a little bit, but the orange, when you see orange, think multi-mode. When you see yellow, think single mode. But we have others here. The orange, the 62.5 micron, the titles OMs, and I don't know that you'll need to know those, but just kind of an interesting, as a point of interest, the color of the jacket gives you an indication of what kind of fiber it is. The 62.5 and the orange here, the 62.5 microns and the 50 micron cores for use for local area networks, and then the distances, the different distances that we go, the 300 meters for the 62.5, quite a bit. That's 3 times what we would have with copper when we use these things. Aqua, 300 meters for large lands, high-speed networks for a large campus, and then the lime green varies. The single mode fiber, tight buffered down there, and loose tube for these things. The jacket color and the ones that we use, the single mode was yellow and the multi-mode was orange when we looked at those things. Wireless is one of those things that we use kind of in an emergency, and I have a number of stories to tell, and one of my stories is right now is the management comes and Friday probably around lunchtime and says, hey, we got a new class starting in this classroom that we don't have anything in Monday morning. No wire is run. We like to use wired connections. There's no wires. We didn't even have the computers in there. Oh yeah, the computers are on the loading dock. They just got here. So get the system set up, and we got fortunate in this case because these new computers came with wireless NICs. They were external wireless NICs, but they came with wireless NICs. So that simplified our immediate problem. Instead of having to run wire to each of the workstations, we can now set up wireless. Easier to install and configure than wired. If we had to, and I think it's had like 20 or 30 machines in the room, if we'd have had to configure them, we probably could have worked all weekend and still not been entirely ready on Monday morning. But what we could do, and we took just a wireless router, and put it in the room. So this will be my wireless router. And then we ran a cable here back to the NOC, to the switch in the NOC. And then we had the wireless radios here go to the workstations that were in the room. We, instead of using the WAN, we did not use the WAN connection. We used the LAN connection, the switch connection, so that these guys actually connected directly back to the DHCP server that was back here to get an IP address, and we disabled DHCP on the router, so that, you know, instead of working all weekend, a couple of hours on Friday afternoon, probably 3 or 4 hours on Friday afternoon, we were done by quitting time. We had all of these, I think probably 25 workstations up and running because it was easier to install and configure than a wired network. The things that we can use, the client systems, the desktop PCs, as long as we have a wireless NIC in it, laptops, tablets, all of the wireless devices that you use, the Internet of Things that we have going on. Somebody had, and I think that I don't see it lately, or maybe they're just not advertising it, in my neighborhood, a new thermostat that was wireless. And I know it's a new thermostat because that was the title of it, new thermostat. It showed up on the wireless. So the wireless, in order to do that. Wireless, as we know, is not nearly as secure as wired, because where does it go? Everywhere. But it enables users to connect to the local network or the internet and remain mobile. We can move around. You may be using wireless at home. I'm using a wired connection. But use a wireless in the house. Use it for the tablets. Use it for the phones. To do these things, we can remain mobile. And it's really difficult to plug in the tablets and to plug in the phones because they don't have any place to do that, obviously, to do that. Easier to install and configure. Instead of taking the entire weekend to try to wire this thing up and probably not getting there, we were able to set it up in just a few hours. When it's difficult or impossible to connect using wires. One of the things that you can do, let's say that you have two buildings that you're trying to connect from that are across the street from each other, and the city says, no, you cannot run a piece of coax or a piece of fiber or anything across the street. We could set up a wireless bridge in order to bridge from one of those to the other, to use it in an area where it would be difficult or impossible in order to do these things. Hazardous areas, long distances, inside historic buildings, someplace where they're not going to let you drill holes in the wall. Oh, probably in your house if you're married, because your wife's not going to let you drill holes in the floor or in the walls or run wires across the ceiling or any of those kinds of things in order to go from one to the other. So it is convenient, it is quicker, but the last one there, security concerns. Not configured by default to limit access, although I think that the new ones are. Before you can set a new one up, you have to actually put security on it. But we need to have security, some sort of a limitation on who can get onto the system, and we may want to even put in some barriers to the signal transmission, or change the signal strength so that it's not at 100%, not going every place that it can go. We do these things, a number of things, and again we'll talk about wireless next week, the security that we can do and the other concerns. But right now, yes, we do have security concerns with wireless when we do those things. This is another kind of, let me get rid of my scroll there. Another image here that we talk about a couple of different concepts. I'll try red here for a minute. Red probably not a good color for that, is it? Try and here. A couple of different things or concepts that we can talk about here. You can see the standards down here at the bottom, but the single user MIMO, multiple input, multiple output, but a single user, which means that we can have one device connected at a time. And then the multiple user MIMO, multiple user, multiple input, multiple output, means that we can have multiple users connected independently to the device. And these are the things that have helped us a lot in what goes on. And what we're talking about, multiple paths, and here we have multiple paths that we can go, and I'm going backwards, going from one to the other, but only one at a time. So this is going to be a single user CISO, single input, single output, one connection. 802.11n, we got this MIMO, multiple down here at N, multiple input, multiple output, which means that we could have multiple connections to the wireless and be able to send the signal on all of the connections. And the number of antennas was really the thing that kind of dictated what would go on with these things. So multiple input, multiple output. And on down here, 802.11ac wave 2, and I think this is now 802.11ax. We have a multiple user, multiple input, multiple output, so that we can have more than one user connected to it at the same time. Typically in wireless, and this is another one that introduced a little earlier, but you've talked about CSMA CD on Ethernet collision detection. Wireless uses collision avoidance. Before you can connect to a wireless access point, your system goes to the wireless access point and says, hey, I would like to connect to you and send something, a RTS, request to send. And the wireless will then allow you to send with a CTS, a clear to send signal. When you connect your device, your wireless configurations, it also estimates how much time you're going to need for this thing. So you do that. 802.11n was the big leap. If you look here, 600 megabits per second from 54 megabits per second. Big leap happened there. And then the AC, even better. And the frequencies to look at, the 2.4 gig, and we'll look at the standards here in just a minute, the complications of the 2.4 gig. But we are at a